excellent. Thank you for the introduction. I think I'll say right off the bat that I am definitely not the main person on this project. I'm presenting on behalf, and I did help a bit with the kind of security side of it, because we're talking about metadata and making it secure, basically, especially sensitive metadata with PII in it, or publicly identifiable information. So just a shout out to Chris Seal, he ran the project, and also to James Love. He's the kind of main developer who implemented the solution, and I have never done a presentation for someone else who provided so many resources. And we had a few meetings, so he was very, very valuable and knows a lot about this topic. So thanks to both of them. So like I said, we're talking about metadata and making sure that it's secure. And we want metadata with our data, and we're going to talk about our kind of case study soon. We want our data to be fair, and that's why we want to provide metadata with it, to provide more information about it, where it's coming from, what it's associated with. And in our example, we're dealing with lots of data from scientific instruments. So think electron microscopes and things like that. The main problem is that in our kind of problem area, we had a lot of sensitive information, primarily things like NHI numbers, and we don't want that information to just be available to anybody. And basically, I remember when James first told me about this, he gave me the description of think about this data as a professor's desk, where you've got files everywhere, you've got disks, you've got notes, you've got papers printed out, you've got files on your computer. But when we're talking about instruments, we're talking about, obviously, digital files. And I never really knew how this happened when I was younger, I think, how you got such a messy desk or a messy data, and then I had children, and then I understood all about it. So I think the goal was we want to ingest data from these scientific instruments into a central location. We want to store metadata with that data as well, and that was a key point. If you recognize the little icon up the top, it's a project called MyTardis. I don't know if anyone's familiar with that. It came out of Monash University, but we use that as kind of like an underlying infrastructure for how we centrally manage this data. But there was a kind of problem that came along with that, which we wanted to securely store some things. We'll see that in the next slide. So a bit of an example of data flow. You have some sort of user, researcher, technician. They use some sort of scientific instrument. It gets uploaded, and at this point in our project that we did, we had researchers populate metadata when they actually uploaded it. We had a variety of different kind of scripting so that they could, when they uploaded data, they could provide information about, date and time, maybe patient information. And this was the point where we kind of took that data and made this special thing into an RO crate and added some extra support. We'll kind of see this in the next couple of slides. And from there, in MyTardis, we stored files, just like image files, archive files, things like that. We stored that in an object store, very similar to S3 if you're from the kind of Amazon world. And we also stored metadata into a database. But a key point was that we wanted to, and of course, on the way to actually use it, when we're looking at it from the other point of view, not the person who's uploading the data, they would connect to MyTardis using some sort of laptop and see this information. It's a little bit of a unusual bit here. I don't think this diagram really does it kind of justice, because it's not the same person who collects the data to who uses it. We've got a lot of different users. They've got different roles, different access. Okay, so like I said, the sensitive metadata was a big problem. So we were linking, the scientific data that we collected to people. And people have, specific properties that are sensitive. NHI number, I never knew what this was until COVID was a thing. I don't know, maybe I didn't go to the doctor as much as I should have when I was a bit younger. But yeah, your NHI number links you to the national health system. Something else that was important, not just sensitive metadata, we wanted disaster recovery. So we've got a little image there of we're based in Auckland at the Auckland University. That's a little diagram of all the volcanoes. What would happen if the worst happened and our data center caught on fire and burnt down? And I think a lot of the time when I was talking to James about this project, we really wanted to make sure that the metadata associated with the raw data was saved and linked to it, because without that metadata, we didn't have much use for the original data. And how would we do this? Maybe just a show of hands. Who has heard of RO crates here? Okay, so a few, maybe almost half. This was news to me after coming back from the private sector. I'd never heard of RO crates. Basically, it's a way of collecting data and metadata, so information about that data. And it's actually really simple. All it is just think of like a normal file system where you have a folder. Inside that folder, you have heaps of data, files. We've got some examples there, software maybe, research papers, PDFs, images, archives, any sort of data. And then you would have this associated metadata with it, which is just one single file which describes all of that data. I'm never good with kind of visualizing this, so we've got an example in the next slide, which hopefully will make it make sense. And one really interesting thing is that it uses this technology called linked JSON. So maybe we'll have an entry about a specific file, and it will link to the researcher maybe that owns it, or the scientific instrument that created it. So, two different types in RO crates, two different types of data. One, we have actual data, files and stuff like I've talked about before. So in this example, we've got a data set, and it's just normal JSON, as you can see, with key value pairs. A normal data set with an ID, and it's also, the bottom example is a specific file. And we can see in this data set example, we have an ORCID ID. So this kind of links a data set to a specific owner in this case. We've got the owner's, information there. So data entities, all about the actual data we have. Context entities are all about who owns that data or additional information about the data. And we've got another example there about a person. And every time we see the kind of @ symbol here, that is linked JSON. It is linking to something else. The type is an example of this case. We've got a person. We can also see on the data entity side, we've got a type of a file. And basically, we can link these together. So we can say, hey, this person owns this file. And that's the main purpose of it. But this is not what we wanted to do. We wanted to put secret information in there that was sensitive. So we decided to kind of extend this format to store sensitive information. How would we do that? Since we're talking about JSON, it's a lot about strings. So we kind of did a few different options and went through a few different architecture examples, and we decided that PGP was what we wanted to use. And one key piece of information was that we used PGP and public key encryption because we had multiple people who wanted to access things. Say, for example, you've got a project lead. Maybe they could access everything in the data set. Maybe you also had a PhD student and they were doing a lot of the analysis. Maybe they should only access specific other things. So this really lends itself to PGP, where you have the public key, private key mix. And of course we use the open free version, and it's also very robust. It's been around for a long time, very accepted technology. It has a few negatives which we'll kind of see along the way, and of course we wanted to use RO crates like we've talked about, and we have libraries that work well with this already, so we could leverage those. I always thought this was hilarious, even before I understood what public key encryption was, is that someone saying, I've been posting my public key for years, but no one seems to use it. It's a difficult technology to use. And then he says, maybe I should try posting my private key instead, which is, very dangerous. I never knew what to do with these things when I first kind of got into security, and it's confusing. We hide a lot of this complexibility from the researcher. They do not see this kind of public key operation. So what actually happens when we have a sensitive field in metadata? and we want to encrypt it, what we did is we extended the RO-Crate library to do a few extra things. And basically, maybe we should not even bother looking at this, but we just kind of had a field and we were like, hey, we need to encrypt this. PGP, encrypt it, use a specific key. And then when you read the RO-Crate again, it'll decrypt it on the fly. So this all happens kind of behind the scenes. The user's not involved. Pictures always help. This is an example of we've got the same example as before. We've got a person. That first block up the top there is a specific person. And we can see we've kind of got this new interesting field here, which is a public key fingerprint. And then we also have the second field, so we've kind of got two blocks of data. One at the top, that's a person. The one at the bottom is some sort of specific metadata about something. In this case, it is documenting a medical condition. And we can even see that we've got some sort of type, and this will link to the specific structure of a medical condition type. It's kind of like programming. There is some sensitive information in here. We've got a diagnosis, basically. That is sensitive information to a specific person. And you can imagine too, what if there was an NHI number in there as well that could link the person to a diagnosis, then that's something we want to make sure is secured, and only specific people should have access to it. And like I said before, the public key fingerprint. And this is how we're going to encrypt it. Josiah has a public key. They are allowed access because we can see in this encrypted to field down the bottom here, we can see that same ID linking them. And this is a lot of, it's quite technical, but I think the good part is that it happens behind the scenes. But it's nice to kind of investigate about what's happening and why. If we encrypt it, we get a different type. Basically, this is the same document. Up the top is exactly the same. We've still got the same person. This is after it's been encrypted. And we can see down the bottom here, we have an encrypted graph. That's just a message. We've taken that diagnosis or NHI number, we've taken the public key of the person who owns it, and we've encrypted it. And we could actually add a bunch of people here who could access it. One drawback from PGP was that you can obviously see this is very large, this encrypted message. We've gone from a short string that was a few characters to a big whopping encrypted string, which is kind of like a default size. Due to the amount of data we had, we're talking about scientific instruments and ingesting this data, huge. So in our use case, a tiny string that was encrypted becoming a bit bigger was not a deal breaker for us personally. Depending on the situation, you could have a kind of different solution. Okay, basically we took all this metadata, which kind of is, you don't really see it operating when you're using MyTardis to access data, but it's more happening in the background. And we would actually put these RO crates, we would store metadata in the database, but also put an RO crate that was encrypted alongside that data. And the whole point was to keep that metadata available and also secure at the same time. We did a lot of stuff about ACLs and users, and as you can see, there were kind of got a few different users here. Some people that would be allowed data or denied data. It's quite a flexible model the way it's implemented, and you can basically specify who this data gets encrypted for and who it doesn't. Some future stuff that's happening at the moment. James is working on getting this accepted into the RO Crate standard. It basically just adds a couple of things to the standard to encrypt things. That's the summary of what we're doing. He's also very interested in looking at getting it towards 5 safes crate. So it's another type of RO crate, about 5 safes. I don't know much about that project, but it's to do with trusted research environments. And we're also looking at using it for data archiving at the university. Okay, thank you very much for listening. I've put my email up there in big letters because I was thinking if anyone had questions I couldn't answer, maybe I could forward them to James. So thanks, everyone.
Anyway, So you said you were hiding the private key from the user. How does that work? They don't even get given the private keys into the system somewhere for them to decrypt?
To decrypt, they would be the ones who would have to decrypt it.
So they would have to have the private key.
So they would have the private key, yes. Part of the system is that they would have to make a private key in the kind of initial phase back when they're uploading the, I'll kind of go back to the first one.
They use the system, basically.
Yes. So the first time they kind of come to this sort of system and they're the end user, we would have to get them to make it while they're making the crate, or of course they may not be that user who's actually doing the scientific, instrument data collection. We would have to, get that information from the user.